radioactivity. In the case of radioactive substance, whenever the disintegration process is going on, the rate of decreasing of nucleus means the disintegration, the rate of disintegration or the radioactive substances, whenever it is decreasing, then it is which is directly proportional to the number of nucleus present at that instant. So in that case of whenever the disintegration process is going on, then the disintegration per second, whenever the nucleus are disintegrating, the disintegration per second is considered as is called as activity. The disintegration, a measure of, means the number of nucleus are disintegrating per second can be considered can be called as activity, that is denotes with R, means a measure of the number of disintegrations per second. Means it is second, if in case of if you have the lot of number of nucleus are present at that instant, then the disintegration process also same term. Means if the large number of nucleus are presented there, the disintegration will be in the large amount of disintegration of nucleus will be happened. So that the measure of the number of nucleus present disintegrating at per second is called activity. Means the rate of disintegrations is called activity. In that case, we know that the n be the number of nucleus present at that instant, then the activity which is equal to the number of the disintegrations per second. The number of disintegrations per second means that is number of the rate of disintegrations will be delta n by delta t. Means delta t means changing of nucleus, means the decreasing of nucleus. So that's why if we want to decrease how many nucleus are disintegrating, the number which can be taken, so that the activity is denoted with R. So mod R is equal to mod delta n by delta t. Means the number of nucleus per second with time, with respect to this time, that goes on decreasing. Decreasing means whenever the number of nucleus are decreasing, means the sum of the nucleus remains. So that here the delta by delta t into, we know that from the law of radioactive decay, that is n is equal to n naught into e power minus lambda t. Here n be the number of nucleus at initial state, at t is equal to 0 time, the number of nucleus are there, n naught is there, and the n be the number of decreasing, and lambda be the decay constant with time. So by substituting this n is equal to n naught into e power minus lambda t, if we differentiate that one, then we can get that lambda n naught into e power minus lambda. Because of mod, we don't get any negative symbol. So that means the number of disintegrations per second, the number, what is the number, how many electrons, how many nucleus are disintegrating, that is the number. So that's why we are taking that positive. So R is equal to lambda n naught into e power minus lambda t. Means by differentiating this one, we can get this formula. So from that formula, R is equal to R naught into e power minus lambda t. R naught into e power minus lambda t. So here where R naught is equal to lambda n naught, it's a decay rate of, decay rate means the number of nucleus disintegrating per second. The decay rate can be considered as R naught is equal to lambda n naught is decay rate at a time t is equal to 0 at initial state. So t is equal to 0, so called, it is called as a initial activity. It is also called a initial activity. So that whenever the nucleus are disintegrating, means the number of nucleus are disintegrating per second with the R, and the activity is or decay rate is R, and at a time t, certain time t, then the number of undecayed nucleus, means the number of undecayed nucleus at a time, after time, some of the decays will be possible. Means the decreasing of the decrement of nucleus, means the disintegration of nucleus will happen. After t time, some of the nucleus or undecayed nucleus also there. So that the n be the undecayed nucleus after time t, when the decay rate is R, after time t, then undecayed nucleus are n at the same time. So that's why we can say that R is equal to lambda n, because of, we know that is a minus delta n by delta t is proportional to n, So that's why here we can get that by taking the proportionality constant, by removing the proportionality constant, we can get that lambda decay constant, that is delta n by delta t, which is equal to lambda n, which is equal to lambda n. Here we know that lambda n by lambda delta n by delta t will be the delta n by delta t will be the disintegrations, the number of disintegrations, the rate of disintegrations, the rate of disintegrations. So that's why here we can write that is r is equal to lambda n, because of we know that the rate of disintegration is called as a activity, that is denoted with r. So that's why r is equal to lambda n be the activity. This is about activity. Once again, the rate of disintegrations or the measure of activity means measure of the number of nuclei are disintegrating per second is called activity, or this is also called as the rate of disintegrations is called activity. It is denoted with r. By measuring that activity, r is equal to mod delta n by delta t. Here delta by delta t into, we know that n is equal to, from the law of radioactivity K, that is n is equal to n naught into e power minus lambda t. N naught be the number of nuclei present at a time t is equal to 0. After some time t, if the decay disintegration process is going on, after some time t, the remaining nucleus can be considered as n. So that r is equal to lambda n naught into e power minus lambda t. By differentiating this one, delta by delta t, differentiating this one, we can get that lambda. So r is equal to lambda n naught into e power minus lambda t. So from that formula, delta n naught be the which is equal to the r naught, means a decay rate. Delta n naught be the decay rate. So that r naught is equal to lambda n naught is a decay rate at a time t is equal to 0. At a time t is equal to 0, if in case of substituting the t, then we can get the e power 0 is equal to 1. So that the decay rate will be r is equal to r naught. R naught be the r is equal to r naught. So that's why we can get that lambda n naught. So that's why r naught is equal to lambda n naught. It is also called as a initial activity. It is called a initial activity. So that if the decay rate is r after some time t, then the undecayed nucleus can be called n. N be the undecayed nucleus. So that from that equation, by calculating that one, we can get that is r is equal to lambda n. R is equal to lambda n. This is about activity. Then what is the measure of? Means we know that the measure of number of disintegrations per second of nucleus we called as activity. That is denoted with r. Then what is the measures? What is the units of radioactivity? Here the units of radioactivity in type of the measure can be happened in 3 types. Means one is the becquerel unit of radioactivity. One is the becquerel, and another one is Curie, and another one is Rutherford. So the first one is a becquerel. This is the unit of radioactivity. When one disintegration per second, in 1 second, if the nuclei one disintegration is happened, then that is called as a 1 becquerel. So that 1 disintegration per second is called a becquerel. So 1 becquerel is equal to 1 disintegration per second. 1 disintegration per second. And second unit of radioactivity is Curie. Curie means whenever the disintegrations are means number of nuclei are present at the instant of initial time is more, then initially the disintegration process also happened more. So that's why whenever the 3.7 into 10 to the power of 10 disintegrations happen per second, if the disintegrations are 3.7 into 10 to the power of 10 disintegrations per second will happen, then that is called as it is 1 Curie. If the radioactive substance the unit of radioactive substance is called when it is said that when the 3.7 into 10 to the power of 10 disintegrations per second happen, then that is called as it is happened that 1 Curie, means 1 Curie is equal to 3.7 into 10 to the power of 10 disintegrations per second. Means in 1 second the 3.7 into 10 to the power of 10 disintegrations has to happen. So in that case of only we can say that is a measure of that 1 Curie radioactivity is happened. So that is a 3.7 into 10 to the power of 10 becquerel. Becquerel because of 1 disintegration per second. So disintegration per second can be considered as a becquerel. So 1 curie is equal to 3.7 into 10 to the power of 10 becquerel, we can say that. So that here the third one is a Rutherford. Rutherford means whenever the 10 to the when the radioactive disintegration of a radioactive substance is said to be that is Rutherford is said to be that whenever the 10 to the power of 6 disintegrations per second, means in second the 10 to the power of disintegrate the 10 to the power of 6 nucleus has to be disintegrated, so that the when the 10 to the power of 6 disintegrations is happened in second, then that can be considered it's a 1 Rutherford. 1 Rutherford, when the radioactive substance, the disintegration of a radioactive substance is 1 Rutherford, is said to be that when 10 to the power of 6 disintegrations per second happen, then it can be considered as a 1 Rutherford. There is a measure of 1 Rutherford is equal to 10 to the power of 6 disintegrations per second. Also we can consider as a 1 Rutherford, which is equal to 10 to the power of 6 becquerel, 10 to the power of 6 becquerel. This is about the activity and the units of radioactivity. Means whenever the measure of number of disintegrations per second or the rate of disintegrations are called as activity. In that case of activity is denoted with R is equal to lambda n, and the units are the becquerel. Becquerel means 1 disintegration per second is called as becquerel. That is the one of the unit of radioactivity. And second one is a curie. Curie means when the radioactive substance, the disintegration of radioactive substance is 1 curie, is said to be that the 3.7 into 10 to the power of 10 disintegrations per second. 3.7 into 10 to the power of 10 disintegrations per second will happen, then it can be said that the disintegration is a 1 curie of a radioactive substance. It means that is 1 curie is denoted with Ci. So that is 3.7 into 10 to the power of 10 becquerel also we can call. And the third one is a Rutherford. Rutherford means when the disintegration of a radioactive substance is Rutherford, is said to be that when the 10 to the power of 6 disintegrations per happen, then it can be said that the 10 to the power of 6 becquerel or 10 to the power of disintegrations per second is equal to 1 Rutherford. This is about units of radioactivity and activity.